Hi, my name is Landon Johnson. I'm on Challenge 2016 in Math 2000. And so this is the equation of the ellipse, and what you want to do is find the area. So first off, you want to get y by itself on one side. So first off, you can start by subtracting x squared over a squared, and then you can multiply by b squared, and then finally you take the square root of that, and then so you can have y equals square root of b squared minus b squared x squared over a squared. And then you can simplify this out by taking out a b squared, and then the square root of b squared is just b, so you can take b out in front of the radical, and then you're left with y equals b square root 1 minus x over a quantity squared. And then so this is your equation of an ellipse with y equals form. And then to find the area of something, you just take the integral. So what you want to do is take the integral of that over here. And then so you want to make a trig substitution. So in this form right here, you can notice that you can do the substitution x equals a sine theta. And then from here you can solve for dx, which is a cosine d theta, or cosine theta d theta. And then you can go back and sub in. So then you have, and you can take out the b too. So the area equals b times the integral of square root 1 minus sine squared theta times a cosine theta d theta. And then square root of 1 minus sine squared theta is just cosine theta because of that identity. And then here you can get ab times the integral of cosine squared d theta. And then, so it's just a basic integral from here. What I did is I found the area of a quarter of the ellipse, so that's from 0 to pi over 2. So that's why I have the 4 out in front. To find the total area, you have to multiply by 4. So then you have 4ab over 2 times the integral from 0 to pi over 2 of 1 plus cosine 2 theta d theta, because that's the identity for cosine squared theta. And then you can simplify this, and you have 2ab times, and take the derivative, or take the integral. So then you take the integral of 4ab over 2 times the integral of 0 to pi over 2 of 1 plus cosine 2 theta d theta, because that's the identity for cosine squared theta. And then you get 2ab, and then taking the integral, you get theta plus sine 2 theta over 2, and that's over here. And then from 0 to pi over 2. And what you can do is sub back in so you get it in terms of x. So I made some other substitutions and identities up here. And so first off, you can get theta from this, and theta is going to be arc sine x over a. And also you can turn this into 2 sine theta cosine theta, because that's the identity. So eventually you get down to 2ab times arc sine of x over a plus x over a times the square root of 1 minus x over a quantity squared. And this comes from, well, sine theta is just x over a, and then this comes from over here. Cosine theta equals the square root of 1 minus sine squared theta, and we already said that sine equals x over a. So that'll be square root of 1 minus x over a squared. And then you can also change the bounds. So originally it was from theta equals 0 to theta equals pi over 2 over here. And then plugging back into here, you can get from x equals 0 to x equals a. And so you flip the bounds here, and this is what you get. And then you just start multiplying back in, and you get 2ab times the arc sine of a over a, or 1, minus the arc sine of 0, because the rest of this part is 0. 1 minus a over a squared is just 1 minus 1, and square root of 0. So that's why you're left with this. And they have minus arc sine of 0 minus 0. And so that turns into 2ab pi over 2, which equals ab pi.